Alright, so this is the study guide for our first test, the transformations test. So each time before we take a test, I try to do a study guide, which is like problems that you're going to see on the test, but with different numbers, so you can kind of gauge how you're going to do and what you need to study. Alright, I actually have a typo on this one. It's fine on your study guide. This should be y equals 3, x equals 2. Y equals 3, and x equals 2. Okay, so we have a rectangle, it has vertices, blah, 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 graph them. Which of the following gives the line or lines of symmetry about which the rectangle can be reflected in order to make a map, in order to map the rectangle onto itself? So remember, anytime it's talking about onto itself, it wants that exact same rectangle when you get done. So, in our notes, we said that you're only going to use a diagonal line whenever you have a square. We have a rectangle, so it's not D because that's a diagonal line. We also want to choose a line that's going to go directly through the middle. So if I choose y equals 3, that's this line cutting through the y-axis. That's not in the middle, so it's not A, it's not C. You probably can guess it by now, but we'll go a little further. X equals 2 is this line right here, because it hits the x-axis at 2, and that does go directly in the middle. So your answer choice is B. Okay, so we have a parallelogram with vertices, blah, 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 graph them. Which of these transformations will take the parallelogram onto itself? So very similar to that question we just talked about. When it says onto itself, it means which one is going to give us this exact same picture. So, if you do A, you're looking at a line like this. That does not go in half, not A. If you look at B, you're talking about a line like this. That's not in half. If you talk about C, 180 degrees rotation, you would be looking at something over here because you would move 2 quadrants over. And the only one that works, and anytime you see this as an answer choice, it's probably it. A 360 degree rotation is always going to bring you back onto yourself. So the answer is D. Okay, so a rectangle has vertices, blah, blah, blah. Identify a line that the rectangle could be reflected over to result in a rectangle that has the same vertices as the original. Once again, looking for a line that's going to go directly through the middle. If you choose y equals 3, it goes directly through the middle. That's the answer. A. Alright, so for this one, which rotation, not talking about a reflection anymore, which rotation will carry a regular hexagon onto itself? Whenever we're talking about onto itself and we're talking about rotations, this is when you use that formula 360 degrees divided by the number of sides. And remember, the answer could either be the number you get when you do that formula or a multiple of that answer. So because we were talking about a hexagon has 6 sides. 360 divided by 6 is 60 degrees, and that answer choice is right there. Also, answer choices could be 120, 180, 240, as long as it's going up by multiples of 60. Alright, so for number 5, A is at 0, 0, B is at 2, 2. If this is translated 3 units up and 2 to the right, which statement must be true? So let's go ahead and move these 3 units up and 2 to the right. Okay, so that new line looks like this. So this is A prime, B prime. So let's look at it. So A says AB, these are the lines. Line AB and A prime, B prime are parallel and congruent. They're definitely the same size and they're definitely parallel to each other. So A is the answer. You could go through the rest of them, but just think about a translation. A translation just moves something, so it's going to be congruent. And as long as it's not doing a reflection, it's got to be parallel too, because all you did was shift it. Alright, so point P at 2, 3 is rotated 90 degrees clockwise. Pay attention to that word clockwise, because usually in class we talked about counter. So if you remember, 90 degrees clockwise is the same as 270 counterclockwise. So what will the coordinates of the image of P be? So you have to, and I don't know why that's not a question mark, but my bad. You have to know the rule for 270 degrees counterclockwise. Okay, so there's the rule. You have to know the rules in order to be successful on this test. Please don't cheat. I would like for you to actually know them, but there's no way I can police that. So we started out with the pre-image point being 2, 3. The rule says that I'm going to switch the coordinates, and I'm going to make my original y coordinate the opposite sign. So my new point would be at 3, negative 2. And so if you graph 3, negative 2, it makes sense that it went 1, 2, 3 quadrants over, because you went 90, 90, 90, which gives you 270. Okay, so very similar to that last one, we're going to take the same point P, 2, 3, and we're going to, let me try that again, reflect it across the y-axis. So for these, you either know the rule or remember that you can count. So I went over 1, 2 to get to the line of reflection. I would go over 1, 2 again, and that point right there would be at negative 2, 3. So that's how you do those. Okay, triangle ABC has vertices blah blah blah. I've already graphed it. It is translated 2 units right and 1 unit down. What are the vertices of triangle A prime, B prime, C prime? So, if you remember, when we did those rules, anytime we're talking about moving the x coordinate and we want to move it to the right, we would do minus. Anytime we're talking about the y coordinate and, move it to the right plus. And then anytime we're talking about the y coordinate and we want to move it down, we would do minus 1. So you could just add 2 to the x coordinates and then subtract 1 from the y coordinates. And it looks like A is the answer, unless I did it wrong in my head. You could also graph those points if you get confused by the rules. And you could just see, I'm just going to graph them really quickly and show you. Oh, that's not it. 1, 2, negative 1, 4, 2, yeah, and you can see that that triangle did in fact move 2 to the right and 1 down. So multiple ways to do these. Okay, I think this one's kind of hard. Triangle ABC has vertices blah blah blah. Which sequence of transformations will generate triangle A prime, B prime, C prime with vertices at these points? So we're trying to figure out which one of these rules actually works for you to get A double prime, B double prime, and C double prime where you want it to be. Okay, so what you could do is go through all the rules. I'm going to go ahead and give you the answer and then show you how I know it's the answer. So if I look at C, if I do a rotation of 180 degrees, let me do this in a different color, then that's this rule. So let's talk about point A. If I use negative 4, 4, it would have become 4, negative 4. And then I would reflect over the y-axis. That's that one in purple. And it would become negative 4, negative 4. So notice that's exactly where I wanted A double prime to end up, so that has to be the correct rule. So you look at the rules and you do it to the coordinates to see which one's actually going to give you the one that you want. Okay, so which transformation maps each triangle in the xy coordinate to a congruent triangle? So notice that it doesn't even give you a triangle. You could make one up if you wanted to, but we talked about this in our lessons. The only transformation that's going to make it not be congruent is going to be a size transformation. So anything dealing with multiplication. So look at part D. If you multiply the x coordinate by 3, you're going to change the size. Look at part C. If you multiply x by 1/2 and you do 1 divided by y, remember multiplication and division pretty much do the same thing. They're going to change the size. So the only two options you have are A and B. So what I'm going to do really quickly is I'm going to make a tiny little triangle. Alright, and so that's going to be 0, 0. This is going to be 1, 2. And this is going to be 2, 0. And so what I'm going to do is I'm going to take those rules and I'm going to apply them, and then I'm going to graph the triangle and see if it's still congruent. So I'm going to do the first one, A, in green. So the rule says to take the x plus y coordinates, add them together, and then your y coordinate becomes your x coordinate. So these are my new points. I'm going to graph them and see if I get the same triangle. And that's a totally different triangle than the one we had in blue that was a little bitty one. So definitely A is not the right answer choice. So B is the correct answer. You could check it. You could do the same thing with the coordinate points and graph it and make sure that it is congruent. And remember that congruent means the same size, same shape. Alright, so very similar to that last one, which rule will result in a figure that is congruent to the original? So anything that's being multiplied, we're going to go ahead and take out. That's wrong. That's wrong. Oh, and D is also wrong. So the only one that doesn't have any multiplication going on is B. So that has to be the rule. Okay. So P13 is going to be rotated 90 degrees counterclockwise, and then it's going to be reflected about the line y equals negative x. What are the coordinates of P? So what I'm going to go ahead and do is I'm going to write down the rules for 90 degrees counterclockwise and reflection about the y equals negative x. Alright, so I'm going to take that first dot, 1, 3, and I'm going to do negative yx to it, so that would become, let's see, negative 3 comma 1. Yes. And I'm going to graph that. I really don't have to graph it, but I will. Alright, and then I'm going to take that green and I'm going to apply the rule negative y, negative x to it. So that would be a negative 1, positive 3. Alright, and then that's my final answer. That's P double prime. So the green was P prime, and the original was P. Alright, so as long as you know the rules and you know how to apply them, pretty easy. Okay, so a regular octagon has rotational symmetry. What is the minimum number of degrees a regular octagon must be rotated in order to prove this? So anytime we talk about rotational symmetry and we're talking about a figure, use that formula 360 divided by number of sides. So an octagon has 8, and I don't know what this is. I'm going to use my calculator. Alright, so I got 45. So 45 degrees would be the answer. And I don't know if I've said this, but you can always use a calculator in Math 2. Every test we take, when you take the final, and also in Math 3. The only time you can't use a calculator is when you took the Math 1 EOC. And who knows why that is. Alright, I think this one is a hard problem. So AB has points blah blah blah. If AB is dilated, so remember, that means that you have a size transformation dilated. With respect to the origin by a factor of k, it doesn't actually give you a value. You can always just pick one. To produce A prime, B prime, which statement must be true? So let's do this. Since it didn't give us a value of k, let's just say that the factor is 2. So here's my rule for when a factor is 2. So go ahead and do that rule to AB and graph A prime, B prime. Okay, so notice how that line just extended. So obviously the line is going to have the same slope. Alright, it didn't have twice as much slope like it says in part B. That's why it's not B. Part C and D, well, part C says the line intersects the y-axis at 0, 0. That is true, but it wouldn't always necessarily be true. It intersects at 0, 0 because that was what the point was. And then D, the line that passes through A prime, B prime, intersects at 0, 0 plus k, which was 2, and it definitely didn't go through 0, 2. So the only one that you might be tempted to pick besides A is C, and you just have to think it through a little bit. Okay, so anytime something is dilated, it's not going to change the slope of the line. That's all you need to do. Okay, so you send me questions if you have them. We can do a Google Meet. If you're ever on campus, you can come by and see me. Let me know beforehand just so I know to be in my room when you come by. You can hit me up on the Remind app. You can send me an email. So lots of stuff to do. Hopefully you feel prepared for your test. Make sure you know those coordinate rules. And then just always check your work, graph stuff, label stuff. I know it takes extra time and you probably want to just rush through it and get done. I do too. But if you take a little extra time, your grade will be that much better. So let me know if I can help. Bye.